All right, this video is going to talk about how to multiply polynomials. So we're going to start off with a couple of really basic polynomials because we actually already know how to do these. Remember, a polynomial can be any number of terms. So notice up top here, we've got a binomial, 5 plus x here, or x plus 5. We also have a -3, which technically of itself is a polynomial, just a single term polynomial. So how do we multiply the two of them? Well, we're familiar. We know the distributive property, right? We're going to take our -3, we're going to multiply it by x, and we're also going to multiply it by 5. And that's one way, right, simplifying those two statements, to multiply polynomials. Just the simple distributive property. So if you have a monomial, such as 3x out here, right, multiplied by any number of polynomials, so the trinomial we have here, we're just going to multiply our 3x times each one of those terms, and then careful how you do that. So 3x times 2x squared is going to become a 6x, right? We're going to have 3 times 2 is 6, and x times x squared is x cubed. So we're going to get a 6x cubed down here at the bottom. Again, that 3x times -5x, and make sure you keep that negative with the 5x. But 3x times -5x becomes -15, and again, x times x, x squared. Then we have a 3x times 3 over here, which just becomes simply 3 times 3 is 9, and x, well, there aren't any other x's, so just x to the first for a final statement to finish. Again, that's one way to multiply polynomials. If it's just a monomial on the outside, we can multiply by distributing. Now, that also kind of goes toward what we call the horizontal distributing method. So again, if we're multiplying polynomials, well, what do we do when this isn't a monomial anymore? Well, we can still treat it sort of like one by saying, why don't we take that binomial and let's multiply that entire thing, right? Let's multiply this whole thing by 5 and by 3x and by x squared. So we can just multiply the 5 times x minus 2, the 3x times x minus 2, and the -x squared, right? Minus x squared times x minus 2. Now we do a little more distributing. 5 times x will be 5x, and 5 times -2 is -10. So there's where we get these first two statements here. 3x times x would have been 3x squared, and 3x times -2 is our -6x in the middle. And don't forget the negative sign now, the minus sign, -x squared times x, and -x squared times -2 to get a -x cubed, and a plus, right? Don't forget the double negative becomes positive, so plus 2x squared. Now we just need to add our like terms. So very simply, we'll take our x squareds and put them together. We should have 5x squared when we're done there. Don't forget to first list off our x cubed here, though. We do have a higher term there, so that one should go first. And then in the end, we also have a 5x and a -6x here, right? So again, I'm going to start with -x cubed. We've got a 5x squared, right? We got our 2 and our 3 there. 5x minus 6x was a minus x. And then we have that constant -10 when we're done. Again, that's just adding like terms again, using that horizontal distributing method, horizontal adding method when we're done. Make sure you add up all your like terms. Now, another way to look at big statements like that is use what's called a table method. It's just an easier way to keep track of your terms. And what the table method does is it's going to take our trinomial and our binomial up top here, and we're going to write them in sort of a table, or what we sometimes call a box method. Sometimes this will also be called the box method here. So what I'm going to do is, again, I'm going to write those very simply, right, on top and next to a table. So we've got our x squared plus 2x minus 3, right, our first trinomial here, written on top. And we have our 2x and our -1 written down the side here. So realize, again, separating those terms, each one of them gets their own sort of box or sort of row of boxes, column or row to go with. So now what we're going to do is we're just going to multiply what's on the top by what's next to it. So we've got an x squared times a 2x, and that's what gives us the statement in the box, right? So we had our 2, and x times x squared is x cubed. Then let's keep going to the right here. We've got a 2x times a 2x. So 2 times 2 is going to be 4. And x times x, x squared. 2x times negative 3 will be a negative 6x. Then we'll move on to the negative 1, right? We've taken that 2x, we've multiplied it by all three parts, kind of like distributing. So now we're going to move on to the next term, right? That negative 1. So negative 1 times x squared, negative 1 times 2x, and negative 1 times negative 3 becoming positive 3. After that, we just need to add our like terms up again. And again, you could write those all out in a horizontal fashion if you want to. But what I would notice is we have an x cubed in the upper left corner. Then we have some x squareds, right? Kind of kitty corner to each other here. We have some x to the firsts, right? Also sort of diagonal there. And then finally, we have our constant 3. So notice again, we've got our 2x cubed. 4x squared minus 1x squared is 3x squared. Negative 6x minus another 2x, which is our negative 8x. And finally, we finish with the 3. So there we go. Again, that's the table method. It's sometimes easier to keep track of your terms. And then in the end, a lot of times the patterns will sort of be easy to keep track of where are the like terms. And again, you're more than welcome to write out those terms from highest to lowest in order to help us sort of piece together our final answer. Let's try just a couple more, one other method here. When we're multiplying two binomials, there's a well-known phrase called FOIL in algebra that a lot of people like to use. Now, some people like it, some people don't. So again, this is just sort of a suggestion. But again, if you have a binomial times a binomial, it's kind of nice to think of that sort of distributing method, right? Or kind of like we did in the table, taking one of our terms and sort of multiplying it by all three terms in the other statement, right? We took our 2x, right? And then taking that negative 1, right? And running that sort of distributing idea. Well, FOIL is sort of that plan. If you have a binomial, right? It's a good reminder that we're really going to end up with 4 terms. And what FOIL stands for is first, outside, inside, and last. So the first terms, right, would be the front of both of those binomials. So I've got x times x. So the first terms, right, are going to be x times x. The outside, well, when we look at these 4 terms, if we had to think of what was on the outside, right, sort of surrounding them, I would say this one, right, our x and our negative 3 here. So again, we're going to take that x times negative 3. And notice it's kind of like that table method, right? We take x from the first binomial, and we're going to multiply it by both parts, right? We're going to do our times x, and then times our negative 3. But again, it's just a different way of looking at it. FOIL is saying now that's called the outside. Negative 3 times x, right? The 2 outside terms right there. Well, if those are the 2 outside terms, then 2 and x, right? These 2 in the middle are sort of the inside terms, right? So we're going to get a 2 times an x for an inside term. And notice how I'm just adding all of these terms together afterwards, right? X times x, we get a term. So let's separate that with addition. Negative 3x is another term separated by addition. 2x, another addition. And then finally, we've got last here, right? First, outside, inside, last. So the last is just the 2 times the negative 3. And basically, that's our negative 6 there. Well, you'll notice, again, this becomes x squared. Negative 3x and 2x are actually like terms. So they'll just become a negative 1x, right? We can add those together. And then finally, 2 times negative 3 here would be a negative 6. So our simplified answer is x squared minus 1x, right? Negative 3 plus 2, and minus 6. Let's try FOIL using these 2 binomials down here at the bottom. And then if you have any questions, make sure you talk to your teacher. And they'll hopefully be able to help you out if you're lost in any of these ideas, any of these methods. So let's go ahead and do it. First is going to be a 3x squared outside, right? We're going to multiply 3x and 5. I'm going to call that 15x. Inside, we've got that 4x. And last, notice we're connecting that 4 to that 5. Well, 4 times 5 is 20. Then let's add those two middle terms together, which often happens. So we've got 3x squared to start, plus 19x, right? 15 and 4. And don't forget your constant, your plus 20, when you're done. So that would be our trinomial statement we got back, right? A binomial times a binomial. Because those inside terms added up, we ended up with a trinomial. Really, we got 4 terms, but again, those two middle ones added together, we got 3 terms when we were done. Again, feel free to practice some more in your homework. And if you have any questions, talk to your teacher or find a tutor. Have a great day.